Welcome back. In the last pair of lectures, we looked at the surveillance procedures that apply to email and other online services. This lecture addresses government access to a person's prospective web browsing activity. I'd like to take the topic in 3 parts. First, I want to explain a little of the technology behind web browsing. Then, I'd like to work through the distinction between metadata and content for web browsing. Finally, I'd like to address what's known about these surveillance practices. So, let's start with the technology. Suppose Alice wants to load a web page on a particular website. Her browser will send a request for the web page, and the website's server will send back a response. The request might be for a static web page. Suppose Alice is still planning to steal from Stanford. Alice might look up a campus map on Stanford's website. Her browser will send a request, and the website will return the map. The URL, or web address, for the campus map might look something like this. Alternatively, Alice might request a dynamic web page. Imagine Alice wants to know where Stanford keeps its valuables. She might run a web search, say for Stanford loot, and a search engine would provide a response. The URL for the search results page might look something like this. Note the question mark in the middle of the URL. That's commonly used to separate a list of parameters that the user has provided. Here, it's a search query for Stanford loot. A question mark isn't at all necessary, though. The search engine URL could just as well be something like this, with no question mark. Or it could look something like this, putting the search query up front. So, there are conventions in how URLs are structured, and the question mark approach is most common. But there are alternatives, and there's no technical reason they can't be used. So, that's what might show up in the top bar of Alice's browser. When Alice's computer actually talks to the search engine server, the URL gets broken into 2 parts and rearranged. But it's still there. This is just a simple request using HTTP, the protocol that the web's built on. Let me add one final wrinkle to HTTP. Requests usually include a so-called referrer header. You know the web wasn't designed by liberal arts majors, because refer is misspelled. When your browser loads a web page, it usually includes a typo. Anyway, so the referrer header has 2 functions. First, if you click or tap from one web page to another, the referrer tells the second web page where you're coming from. Here, Alice was linked to the search engine query from a social network message that Bob sent. The second way in which the referrer header works relates to content embedded on a web page. Every image, video, and so on requires its own HTTP request. When your browser issues requests for those embedded resources, the referrer header is set to the web page's URL. In this example, Alice's browser is loading the search engine's logo. In the process, it's sending a referrer header, which is the URL of the search web page. So, that's a very quick sketch of how HTTP works between Alice and a web server. Something has to get the HTTP traffic from Alice to the web server and back, of course. And that's where other protocols come in. Computer scientists usually think of a network as a set of layers. HTTP is towards the top, since it travels over other protocols. Below it is TCP, the Transmission Control Protocol, which makes sure data arrives intact. Below that is IP, the Internet Protocol, which lets devices on the Internet send data to each other. Each device has a numerical IP address. It works roughly like a phone number, in that it's used to route communications from one device to another. Finally, below IP, there are some other protocols for moving data on more local networks. Another way of visualizing the layers is as a set of wrappers, like layers of an onion. The outermost layer, IP, moves data between Alice's laptop and the web server. Nestled in the IP traffic is TCP traffic, and nestled in that is the HTTP traffic. Historically, the idea was that when data moved over the internet, intermediaries would only look at the IP layer. They wouldn't look at what was stored inside. It was just a black box. More recently, internet intermediaries have been peering inside IP traffic. That's called deep packet inspection, and it's a quite controversial practice. Alright, so there's a somewhat simplified overview of how web browsing technology works. Now let's match that technology against surveillance law, and in particular, the distinction between metadata and content. Recall that prospective collection has three categories. First, dialing, routing, addressing, and signaling. Second, content. And third, information that isn't content, but also isn't DRAS. And recall that DRAS can be accessed with a mere pen trap order, issued on just a self-certification of relevance. Content, by contrast, requires a wiretap order. As we've seen, that's like a super warrant, and it's very burdensome for investigators to obtain. There is fairly widespread agreement that Internet Protocol metadata is DRAS. It's unprotected by the Fourth Amendment, and it's available with just a pen trap order to an internet service provider. That includes information like IP addresses, when packets of data are sent, and how large packets are. The legal rationale is straightforward. Internet Protocol metadata fairly closely parallels telephone metadata. IP addresses work a lot like phone numbers, and packet timing and size are a lot like call time and duration. Some computer scientists have emphasized that a pattern of packets can be highly revealing, in a way that phone calls might not be. But those views haven't gained traction in legal circles. So, that's the IP layer. Where there's much more legal disagreement is the status of HTTP metadata. In particular, there is not consensus on how URLs and referrers should be treated under ECPA and under the Fourth Amendment. There is essentially a spectrum of views on the status of URLs and referrers. At one end is the notion that URLs and referrers are always DRAS, and therefore always attainable with just a pen trap order. The Department of Justice has sometimes hinted at this view, and in fact, it requires local federal prosecutors to strategize their URL pen traps with Maine justice. A couple courts have also suggested that URLs and referrers are DRAS. The basic argument is straightforward. It says, look, a URL is just a web address. DRAS includes addressing, so URLs are covered by the Pen Register Act. And URLs are knowingly given to a business, so they aren't covered by the Fourth Amendment under the third-party doctrine. That's the view at one end. The perspective at the other end is that URLs and referrers are never DRAS. It's a view that's had some popularity among scholars, though to my knowledge, no court has expressly adopted it. There are a few arguments that get made in support of this perspective. One is that calling a URL an address is just a fake-out, a total technical misunderstanding. Addressing, in this context, is about physically directing the flow of data. The Internet Protocol has addresses since they make sure data gets to the right place. Domain names like stanford.edu are also addresses, since they also play a role in getting data physically to the right place. URLs, by contrast, only kick in once data has arrived at a web server. They specify what information the web server should return, not whom to return it to, and not how to get it there. Another argument in this line of thinking is that URLs are like post-cut-through phone digits. You've probably encountered an automated touch-tone menu before, with an airline or a bank or so on. The numbers that you press after your call has been connected are called post-cut-through digits, and several courts have held that those digits aren't DRAS. Legal academics have argued that post-cut-through digits are the best analogy for URLs. They're information provided only after you've made a connection to a business. A final argument for this perspective is that URLs inherently give away content. If you're looking at a book on Amazon.com, for example, the URL probably has the name of the book in it. And if an investigator just loaded that URL in their own browser, they'd see the same page you were looking at. So there's not too much point in protecting web content once URLs are available. Alright, that's the critical view. The third view is in the middle. It says that URLs and referrers are partially DRAS. I think it's fair to say that this is the majority perspective in the courts. The idea is that URLs and referrers are DRAS, but they can also be content. And as we saw, the content category trumps. There is some discussion in the Pen Register Act's legislative history, I would note, that supports this view. It seems to be potentially what Congress had in mind, to the extent Congress was actually thinking about the issue. The middle way poses a substantial challenge. It requires us to figure out which parts of a URL are DRAS and which parts are content. There is a definition of content in ECPA, I should note, but it's not very illuminating. In fact, a quick check of a thesaurus says substance, purport, and meaning are all just synonyms for content. So courts don't have much statutory guidance in this area. And the Supreme Court hasn't done much to clarify the meaning of content under the Fourth Amendment, either. At least this much seems to be fairly consistent in how courts are coming down. If a user affirmatively provides some sort of input, like a search query, then that's content. And it really has to be. Otherwise, the warrant protections that we previously saw for online searches would have a gaping loophole. So that's user-provided input in a URL. The domain name of the website, courts have fairly consistently held, is DRAS. As for everything between, that's totally unclear. And recall that it can be very difficult to distinguish user-provided input in a URL. Not every website uses the question mark approach. And sometimes what follows a question mark wasn't actually provided by the user. Here's our other example from earlier. Again, the domain name is DRAS, but the rest of the URL, here asking for a map of campus, maybe it's content, maybe not. The courts just haven't been very clear. I've pulled together some case law, roughly divided by courts that think a URL is sometimes content, and courts that seem to think a URL is not content. I don't at all expect you to chase down these citations. They're just for your convenience if you want to do some further digging. There is one point I'd like to emphasize about the case law on this topic. Much of it arises in the context of consumer privacy litigation. The very same provisions of ECPA that restrict the government also restrict private businesses. Courts have generally not been very sympathetic to consumer privacy class actions. But in the process of throwing out civil lawsuits, courts have taken some pretty narrow views of URLs as content. Those narrow views subsequently apply when the government seeks a pen trap order. Alright, that's all I wanted to say about how URLs and referrers are a total mess under federal privacy law. Last, let me briefly address data. And there really isn't any. federal reporting on pen trap and wiretap orders lumps web surveillance with email surveillance. And businesses that provide transparency reports also don't clearly distinguish web pen traps from email or phone pen traps. So, it's very clear that law enforcement agencies have been seeking pen trap and wiretap orders that they then serve on internet service providers. It's also very clear that law enforcement agencies have scrupulously required internet service providers to facilitate pen traps and wiretaps under CALEA, a statutory scheme that we'll discuss in the next section. As for how often law enforcement uses ISP pen traps and wiretaps, and exactly what's covered, we have pretty much no information. So, that's it for data on government surveillance of web browsing. In the next 2 lectures, we're going to explore cell phone location tracking. We're going to begin with historical tracking records, and then we're going to turn to prospective tracking.